Okay, so all right. So shall we start?
As you want, or we can wait a couple of minutes more.
Okay.
Just in case.
Okay, no problem. This is the last session of the day, so we have a few time of flexibility.
Okay.
I'm going to make a picture of this. Okay, so I think that we should start the session anyway. So if you're okay, Raul, we should start.
Yes. Okay. So
yeah, people will be joining if they can. So I would like to welcome to this session, this Ruc-Aps online session, Raul Poler and Mareva Alemani with their work about optimization service for agriculture value chain. It's a demo presentation. This is the team from the CGIP. Not sure, I forgot the English translation, so we say CGIP. You can explain that later at some point. They belong to the Universidad Politécnica de Valencia, and they're going to show us a tool that is already being implemented and with potential to be used in industries. I'm not sure if Mareva, would you like to say something before Raul can start? Your microphone is off, by the way.
Yes, Raul is the director of the CGIP, and he has followed the Ruc-Aps project since the beginning. So he's very expertise in mathematical modeling and also in the implementation of tools, in computer tools. So I think he can show us a very interesting service that we think that is useful for those people that have no knowledge about mathematical optimization and can help in make better decisions in all industries and more specifically in agri-food supply chains. So I think that is very valuable for this sector. So anything else?
Okay, so I start. As commented, I'm Raul Poler. I'm a professor at the University Politécnica de Valencia. My teaching activities and research also is in operation management, operation research. And I'm the director of the Research Center of Production Management and Engineering. This is the English, Jorge, for the CGIP. Okay, let's start with the presentation. As you know, this is a demo of a tool. So this is a continuation of the speech of Mareva last week. And we start from the problem. As you know, in the Ruc-Aps Work Package 8, we have identified and analyzed different decision-making optimization problems. And one of them is related with the improvement of vegetables quality in small-scale farms through the collaboration between the different stakeholders in the supply chain. Once we understood the problem, we developed a mixed integrated linear programming model based on the selected investment to carry out by the stakeholders in the supply chain, mainly the retailers, and also the product flow through the supply chain in situation of supply and demand imbalance, when the demand and the supply are not balanced. This is the model, and we experimented with this model, and our research showed that collaboration programs increase both the supply chain profits and also the consumer satisfaction level. where there is an imbalance between demand and supply. That is the purpose of this model. To the tool. So once we prove that the model could be useful for small-scale farms, we built a tool in which we have implemented the mathematical programming model, and that can solve different instances of the problem. When we designed this tool, we thought that it would be the simplest for the user, which means that we had to hide all the complexity of the mathematical model, and that the user could easily provide the input data of the problem and obtain also easily the output data and the solution to the problem. Before to go to the live demo with the tool, just a few words on the options that the company has for solving optimization problems. Nowadays, a company can decide to have the hardware and software on premises or have it in the cloud for different enterprise applications. In the optimization field, if a company decides to acquire hardware and software for optimizing the problems that the company have, the company will need first a computation server, and second, buy solvers licenses. And normally, both hardware and software will be used by the company in a punctual manner when an optimization calculation is required, maybe once a week, maybe 1 hour per day. This could mean that wasted investment because the computer or software is not used all the days or all the time, but only in punctual calculations. Also, such hardware and also the software should be maintained by the company. So this is the one option. And the other option is the cloud. Is to use the cloud. Cloud computing, as you know, is the on-demand availability of computer servers. So the servers exist, but in the cloud, in other installation, not in the company. Normally, it's for its data storage, but also for high computing power. And this in the cloud, if a company uses the cloud, don't need an active management by the company of nor the hardware and the software. And concerning optimization, the company can pay per use, for instance, not paying the license, the entire license for all the year, but per use. Both the hardware and the software, which could mean lower expenses than on-premises option, obviously. And on the other hand, one of the most important decisions of a company face is whether to use commercial or open source software. As you know, commercial software is obviously created and supported by profit companies, for instance, Kurobi or IBM, that normally sells licenses and for the use of the software, and those companies obviously are driven by maximizing profits. So normally this software is expensive. On the other side, we have open source software that normally is overseen by dedicated communities of developers that contribute to improve the software continually and decide on the course of the software based on the needs of the community. So there is a community, not a company or an enterprise, that is developing the software and is opening the software to the rest of the people. And the companies can use it, obviously. One of the most important characteristics for deciding is the cost of ownership when decided to use an open source software or a commercial one. There are many other advantages and disadvantages, not only the cost of the software. And on the mathematical programming optimization field, that is the field that we are talking about, obviously, commercial solvers like Gurovia or Ciplex have better benchmarks than open solvers that, for instance, CBC from CoinOR. But we should take into account also that the time needed for solving a mathematical programming model also depend on the computer. And an option is to use open solvers and computing services in the cloud. That the companies can pay per use. So the companies don't need to acquire a server, a hardware for being a server for computing those models, but can pay per use. Also, in some cases, the mathematical programming model are not so hard and can be solved in a reasonable time using open solvers. So in such cases, the decision is clear to go for open source solvers and software. Okay, so our proposal is an optimization as a service tool on the cloud using open source software. In this case, we have implemented it on Python on the backend, and we have used React and Redux for the frontend. And we use Google or our tools as solver. So we use open source software to build. We have used this open source software to build our solution. So let's, after this short introduction, let's start with live demo. This link is the link to the optimization service. A company can have a user and a password, only one, to enter to the service, or a company can have different users for different employees grouped in the company account, for instance. So let's switch to the browser and let's see how the tool works. So this is the entrance to the tool, the login and password. Let's put my user and password, and we have inside the tool. So this is the main page. Is the help page in which the user can read about the problem that the optimization service solves. The model is not presented here, as we think that this should be transparent for the user. But if the user wants to learn about it, there is a link, you may see here a link to a paper. And if this link explains in depth the mathematical programming model. In this page, it is explained the input data. We start with the input parameters here. This is important for the user because the user will use this tool uploading this input data. So we need to explain very well what are the meaning of each of the different data files that the user should upload. Here you might find the list of all the files which should be uploaded as input data. We have decided to facilitate as much as possible the preparation of such input data to the user, using tabular data that the user can prepare for instance, in Excel or Access or another spreadsheet or database, and then cut and paste the TXT files. I can show you briefly. For instance, this could be the data that the company has. These are the different files. They would be at the end the different files in this spreadsheet. Okay, and just copy and paste this data in a TXT file, but we name these files .tab files. We have prepared the input data. Each of the files have a concrete name. For instance, the data farmer quantity. This is the first one. and represents a piece of input data. In this case, is the quality of each vegetable to be produced by the farmer at each period. Or this second one, that is the data price, that is the price of selling 1 unit of vegetable at a certain quality from a farmer through the farmer cooperative at one market in a one period. And besides the tabular input data, the input parameters are specified also in an additional file that you may find here at the end. That is called data order.tab. And in this case, we have, for the model, we have 3 different parameters: the maximum skill level of the CP, the available budget of the CP investments, and a parameter that is alpha, this is the percentage of quality improvement with each CP skill level. So the help page continues explaining that once the user has uploaded or updated the data, the user can solve the model and obtain the solution and visualize and download the results. So the results are saved again in a set of .tab files, and each file corresponds to one decision variable. And here is the description of such files. For instance, the quantity of farmer from farmer to farmers cooperatives. This is the first one, and so on. So this will be the results of that the user will obtain. That contains the different, we will see at the end of the demo, that contains the values of the different decision variables that the problem will solve. So once read and understood this help page, let's go to the parameters page. This is the second one. And here, the user can drag and drop all the input data files, or just the ones that should be updated. If the user has previously uploaded a previous version of files and only need to update one of them, the user can upload this new file and then go to solve the solution. So let's me take the files here. I have the files prepared. These are all the files for a new problem. So I drag and drop the files here. And this is the message that the file has been recognized, and we can proceed to the upload of the files. So we click here in upload, and all the files has already been uploaded to the tool. Now we go to the solver menu, in which, as you can see, there is very easy to use because there's only one button that is solved. The user only needs to provide a name for the folder, in this case for storing the results. For instance, let's put today. And R3, because I think I have used it R1 and 2. And once we have, the user has provided this name for the results for the solution, just he or she should click the button and wait for a few seconds, I hope. And at the end of a few seconds, it should appear a message saying that, okay, yes, the solution is now available in the menu of the results. So let's go to the results menu. So you may see that here there are different solutions, and the one I have uploaded, I think, is which one? I put the R3 or R2, I don't know. In any case, it's the same for the solutions. So by clicking in one of the folders, one of the solutions, a set of tables with the solution for each decision variable appears. So you may see here the different decision variables. For instance, if we go to this one, to Q, uppercase Q dot tab. If we don't remember what it is, we can go to the help menu again and check what means the variable Q dot tab, that is the quantity coming from a farmer and sold by a retailer. Okay, so let's back again to the results. And here, again here, we can see by default 5 rows for each table and navigate through the pages. So we can see the different values of the result for each of the indexes in this variable. We can also select the amount of rows that we want to see, or we can say all. We can select all, and we can check all the values of this table. So let's go and navigate. You may see that the table is a bit large. And at the end of the table, if we go at the end, there is an option, because the user normally, the user can visualize the solution, but normally the user wants to download the solution. So by clicking here in export to CSV, the solution is downloaded and stored in the computer. And CSV, as you know, is a quite standardized format and easy to load into a spreadsheet or a database. For instance, let me switch again here. I have the different variables, the output data of the decision variables converted to X file. And we may see here, for instance, the Q1. And this is the result of the problem that we have solved for this variable. And again, and also for all the rest of the variables. So coming back. And we can see and download all the variables, as you can see here, and we can provide another set of input data for instantiating another problem and obtaining a different solution. Or we can modify one of the input data. Imagine that the user has modified something regarding the price, so has modified only this input data regarding the data price, and the rest of the data remains. And the user only need to upload this new data price.tab file and solve again, and put a different name to the solution and obtain the different solution. Okay, this is up to here is the live demo. As you may see, the tool is very easy to use. Let me back to the slides, and I will show you a bit more about the inside of the tool. Let me navigate. I have these backup slides, obviously, just in case. And this is what I want to show you. This is the results of all the variables in this problem, uploaded and converted to Excel files. And the tool is now running in Amazon Web Services. And this in the screen, you may see this is the Lambda function coded in Python, which contains the mixed integral linear programming model. And here you might see the expressions of the model, the objective function here, and the different constraints. And finally, at the end of the code, the solve command, which launches the model instance to the solver. And here is the team that have participated in the tool building with Mareva Alemany and Ana Steso for the problem definition and the mathematical model building and testing, and Francisco Fraile as the architect, and Hector Navarro as software developer. And that's all. I think it has been very quick. Yes, 30 minutes or less. And now it's your turn. If you have any questions, comments, or suggestions, it will be very welcome.
Yes. Raul?
Yeah.
Only one comment. It is important also to note that the user can ask for developing a specific model to a specific problem. You can choose from existing models, or we can develop ad hoc models to the user. So I think this is a very important aspect. Also, it's possible, for instance, from one solution to simulate another solutions. For instance, the mathematical programming model show us a result, the optimal solution. Okay, but perhaps the decision maker has additional knowledge that is not inserted into the mathematical modeling, and the user wants to know how is the result changing partially some part of the solution. So we can also measure the impact of these changes, only adding some constraints on the decision variable values. So this potential is also interesting in order to evaluate different solutions for the same data, the same scenario with different solutions, or different solutions under different scenarios. There are the two approaches that are possible to address. That's all.
Yes, the idea of this optimization service is that we can provide standardized models for solving, or algorithms for solving standard problems. This is our intention at the TIB, to use this schema that we have tested in the Ruc-Aps project for the first time, and to provide this kind of standardized problems. But obviously, our idea is to prepare ad hoc models or algorithms for specific questions of concrete companies that wants to use this approach. That means to use an optimization as a service. So using the cloud and not needing to acquire licenses of solvers, and don't need the hardware for solving the problems, but using easy to use tool for solving their problems. And our idea at the TIB is to build and provide this kind of optimizations tools as a service, like this, like we have done here in the Ruc-Aps project.
Right, thank you very much. Is there any question from the audience you'd like to make to Raul today? Anybody? Hello? Well, I have a question for Raul. When we use these online optimization services, how do you see that will be the best strategy to connect with to agri-food stakeholders, people that would like to use? What is the right way to use this tool?
It depends on what kind of model we provide for, and if it's not the same providing a model for a concrete company that can solve the problem in a centralized mode only for the needs of the company, or providing a tool in which several stakeholders will be involved. So in which different actors in a supply chain may participate in the optimization in the model. But in any case, at the end, what we provide is what we take is the input. We take the inputs to the problem and we apply a mathematical prime model or any algorithm to obtain a solution. That means that the collaboration, obviously, it would needed the collaboration with the different actors of the supply chain, but this collaboration is first in the definition of the input data, so they should agree in the input data. There are some parameters in this model, as Maria explained it in this model, that should be agreed between the different stakeholders in the supply chain. And then in the implementation of the solution, as you know, at the end, in this case, for instance, we are providing a solution from a centralized point of view because we are collecting all the data that the different partners in the supply chain are providing, and we provide a solution, saying to the different actors of the supply chain, to the retailers, to the farmers, to the etc., what kind of solutions they should adopt because it's the optimal for all the supply chain. But also, again, it is needed the collaboration in the implementation of the solution, obtain it from a tool like this, obtaining the solution for the whole supply chain. Another option is to implement decentralized decision-making models. That means that each of the companies in the supply chain can use their own optimization tool to obtain, to put the input data, obtain the output data, and with this output data, negotiate with the others that will use, again, their own optimization tools. But the point is that, in any case, in summary, at the end, the collaboration should be done between the different actors in the supply chain, no matter what they use at the end. If they want to use an optimization tool or not, they should agree on the input data, and they should agree on the result that all of them should apply or should be negotiated. In this case, the model can be solved again with a different parameterization, for instance, if they have not agreed in the solution, as Maria has commented.
Sorry, my microphone was in mute. So this means that this particular tool depends on a particular and specific mathematical model. So this means that any change on the reality will imply the generation of a new mathematical model, or can select different mathematical models depending on in which level of the supply chain you are.
The idea we have, the theme is to build a optimization as service macro tool, let's say, and inside this service, the different users can select the different problems to be solved. In this case, the link is only one link to one of the models. And okay. Yes, in fact, if you imagine that a company says, okay, this model, it almost fits to me, but I need to make some changes because I want to introduce a new constraint or have a new constraint, something like this. In this case, such case, we will prepare another mathematical model and another service for this company. So for each of the need, for each need of a user, a concrete user, a company, our idea is to develop one optimization as a service for this, for optimizing this problem. So at the end, we will have a list of different optimization tools, but we will develop ad hoc optimization tools for companies requiring specific needs.
Okay. Okay. Thank you. Is there any other question or comment for Raul? He's presenting today. Well, I have more question actually, if I can, if may ask. I mean, when we talk about data, because clearly your model depends on the amount of data that you have. Do you require full data, or you can work with partial data? Because not always we can collect data. So how that the model works in that sense?
At the end, it depends on the model. I mean, if you have built one mathematical model requiring some kind of data, and the company has not this data, you should adjust the model for not considering this data. So in this case, not considering some constraints, for instance, or to calculate the data, or to use an average data, something like this. So it depends. It's important in the problem definition, it is important to identify first at the end for any of the problems that we want to solve in a company. The company have normally one objective. The company wants to maximize something or to minimize something, or has multiple objectives. So the company knows what they want to achieve. And from this objective, the thing we should do is to identify which input data we need for solving the problem. And the company should collect this data. In some cases, some data are complicated to collect, and we should, or the company should forecast data, for instance. But depending on the data that the company can provide, or the data that is available, we can build a model in one manner or another, a different model, to obtain the solution.
Perfect. Got it. All right. Any additional question for Raul in this moment? Anybody? Alejandro, Horacio, are you there? Pascal, maybe.
Yeah, I'm here. Let me start my video again. So thanks, Raul, for your presentation. Now that we are here, I want also to say thanks to Mareva and to Angel, and also to Anna, because they introduce us to the topic of optimization. That was not something we were familiar with. I was a bit afraid of making this question because it shows the little bit that I know about optimization, but I will make it anyway, just to take the opportunity.
Go ahead, Alejandro, go ahead.
If I make a mistake, my teachers were Mareva, Angel, Ana, and Jorge.
Sin paracaídas, Alejandro.
Yes. I'm sure that you have not a mistake. So.
so I understand that you normally, so optimization is something that is quite common in large industries where the relationship between variables, those that you can change and those that update in response to those changes, with these relationships are known or can be modeled, but also in these industries that understand that making small changes in variables may have strong impact. Once I understood what modeling and optimization, mathematical modeling and optimization was, I tried to discuss with farmers around here, trying to communicate what I understood. And the first challenge that I found was that the models they had, first, there was a kind of how would I say it? Non-belief, or I don't find the word in English, kind of descreimiento in Spanish. They didn't believe in that understanding the model to the detail would have value, because they make decisions for years now, based on intuition on the past, just manipulating one or two variables. What do I plant? How much do I plant? And what do I sell? And all of the rest of the variables are somehow fixed for them. So my question, or the challenge that I find when trying to understand how optimization can be used in this model is, and I will try to state it concretely. The challenge is, how do I show someone that is not from a domain that is used to mathematical modeling and optimization? How do I show them that there is value in this? How do I find the problem that is worth modeling and optimizing? And how do I go about showing that this has value? Not sure if the question is clear.
Raul,
It's basically, if you go to someone that is new, I think that's the case for farmers, for agriculture. If you go to someone that has never heard about mathematical modeling and optimization, how do you show them, or what do you show them first?
Yeah. As you have seen in this tool, we don't show, we have put this link in this paper, but we don't show the mathematical prime model to the user. So at the end, the user wants to maximize or minimize something, and it's our role to build the algorithm, to build the mathematical prime model. This is one option, but we can build any kind of algorithm, not specifically mathematical prime models, to obtain what the user wants, that is to maximize or minimize something. And so I think the user don't need to understand the algorithm, don't need to understand the language of the mathematical modeling language that we are using to build the model, and obviously don't need to understand how the solver obtain the solution. Imagine that we are building an algorithm that is, we are not using a mathematical prime model, but an heuristic algorithm or a method-heuristic algorithm. So the user don't need to understand how the black box works. The user only wants to obtain some benefit, wants to minimize a cost, or wants to maximize a profit, or so on. And our role is to build the model. And in this process of building the model, we know that we need some data, and we know that some data is available in the company, and we should ask to the user, okay, I need this data. So if you want to minimize the cost of your production line, for instance, we need the data regarding your machine's performance, the pieces, the parts, etc., in order to take all this data, build our algorithm that is for you is a black box, and we will provide you the solution. The values of the different decision variables that will minimize the cost. That is what you are looking for.
Yes. Yes. Additionally to what says Raul, I think I agree with you, Alejandro, that in my opinion, farmers thought that the agriculture is very uncertainty, it's a lot of uncertainty and risks, and it's a very complex process. So no tool has all the knowledge in order to provide them with an optimal solution. We usually prove the optimality of our solution constant by means comparing with historical data, we was the profit or the cost, for instance, if they are the objectives, with last decisions from the company, and compare these decisions with the decisions that will be obtained as an output with the mathematical model. yes, then we can compare the value of the objectives with the two solutions. And we can prove that with the mathematical modeling is normally, if it is well modeled, the solution is the optimal, is the best, okay? Then we have also situation with uncertain data. In this case, we can, in some ways, state that our solution is more robust. It depends is the optimal or not, because it depends on the final data that will be in the future, because we estimate the future data, but because it is uncertain, really we don't know what will be the really data. But our solution is robust. It means that the difference between the solution provided by the mathematical modeling or mathematical model do not vary very much in terms of the objective function, depending on the data, on the value of the data, okay? The final scenario. So these are I think the benefits and the advantages of using mathematical models. In this way, we can use mathematical models as optimization tools that provide us with the optimal solution, but we can use also as a simulation tool, providing the mathematical model with other solutions in order to compare the different values of the costs, the profits, the service, customer service level, etc. But it's true that farmers are not used to use this type of tools. It's more usual that the agri-food industry, I'm thinking processor companies, that they use mathematical programming, but not farmers. Farmer is not so used to make this type of decision with this type of tools. But the optimization as a service is, I think, one step in this way, no? Some years ago, perhaps we don't imagine that farmers were using so much technology, and now they are using a lot of technology. So in the future, they will make use of this type of decision-making support tools.
Yeah, thanks. So when you were saying, just now when you were saying optimization as a service, it came to my mind that maybe it's wrong that I try to think as the farmer, as the user of this service, but maybe there is a middle actor, kind of these experts that provide services to farmers that are the users of the optimization. So yes. Maybe it's this one we have to convince and train in how to bring optimization, maybe without saying that it's optimization, how to bring optimization to the farm by using your services. That would be interesting.
Yes, indeed. One of the models that we presented in last session were indeed in a problem derived from La Plata in Argentina. It was because to try to that advisory agencies, that is agencies that can advise farmers about what crops to be planted or another things, perhaps can use this type of tools in order to balance supply and demand, because they have knowledge that the other farmers don't have about all the community. So it will be interesting that this type of organisms can use this type of tools also to advise farmers about how to proceed in some way. Okay. Yes, thank you. Thank you for the questions.
I have a question. Can you hear me?
Yes.
Thank you very much for the presentation, Raul and Mareva. I would like to ask, how is the business model of this solution in terms how much and when the small farmer or cooperative have to pay for that service, and on the other hand, how much time involves a simple process to optimize something? Okay, is clear the question?
Yes.
Yeah.
Okay, thank you.
Concerning the cost of the service, we should to calculate it, but our goal is to provide this kind of services as cheap as possible to companies, because we are also previously I think Alejandro has commented something about large enterprises, but we are convinced that the SMEs also need this kind of tools, and in some cases SMEs cannot achieve or cannot obtain this kind of optimization because they have not enough resources for investing in such kind of tools. So our idea is to offer this service as cheap as possible. That means that obviously, as you has been seen, we are using Amazon Web Services. We are paying for the use of the computer in Amazon Web Services, and obviously we need to recover this cost. But we are calculating that the cost should be of use of the service should be very, very cheap for the companies. It's not the same regarding the building of the solution. So if a company can use already built model or algorithm that we can provide as a service for this company, for this SME, for instance, it will be very cheap to use it. And we try to do very easy to use. Because yes, another option is that, for instance, a consultancy company can use these services in order to provide service to the company. But our intention is that it would be the final user, that the company itself, the SME, that use the service. Obviously, if a company needs that we build a new model, this is another type of cost. We need to invest some hours in order to build the model. And in this case, we will calculate and estimate what would be the cost. And once obtaining this solution, as I said, the service, the use of the service, we expect that it will be very cheap.
Okay, thank you. In terms of the time that a new optimization model need?
Yes, it depends on the model. It depends on the algorithm. We are presented here today mathematical program, a mixed and integrated mathematical programming model that, as you know, for large instances, for large amount of data, it can require a lot of time for be solved. But in these cases also, we can, in the service that we are using, an Amazon Web Service in this case, we can pay for a more powerful server for solving an instance that need maybe in the instance that in the server that we are using now, imagine that a model needs around 8 hours to be solved or something like this, but we can hire another one that reduces the time in 1 hour, for instance, and for the user is enough obtain the solution in 1 hour. But in this case, the cost is higher for us that we are contracted Amazon Web Service, in this case also for the user that wants to obtain a solution in a reduced amount of time. But also, again, take into account that this is one kind of optimization models. There are many other optimization algorithms that we normally implement that could be heuristic, meta heuristics, math heuristics that obtain solutions that maybe are not optimal solutions, but are very near the optimum, and go faster and obtain a solution in less time, in an appropriate amount of time for the user, without requiring to use a powerful solver for obtaining the solution.
Okay, thank you very much.
Thank you.
Okay, I think that we had a very good set of questions. Is there anybody else would like to ask anything to Raul or to Mareva or to anybody? Well, I would like to thank you to Raul and Mareva for presenting this tool. It's been very helpful. I fully appreciate all the time. Also, would like to mention, if Raul allowed me, Raul was my PhD supervisor. Yeah. So I'm very happy that I have the chance to present him his work as he did, like, what was this, 11 years ago, something like that? Well, something like that. That's a long time ago. So thank you very much, Raul, for supporting this. And I hope this will be, you know, an open door for more collaborations with other people in the project. The tool looks really nice. And thank you very much once again.
Thank you. Thank you all.
Thank you, Tom.
Bye-bye.
Thank you for the presentation.
Thank you, Rina.
Thank you.
Bye-bye.
Bye.
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 Ciao.
Bye.
Take care.
Ciao.
Bye.
Chao.
Adiós, Mareva.
Chao.
Me alegro de verte. Okay, ciao. Ciao, everybody.
Ciao.
Bye.
Bye bye, everyone.
Bye-bye.